This is LENA, Lecture Notes Annotator. LENA is a generative AI tool for transcribing audio recordings and text processing. It is configured to produce lecture notes, identifying the important parts of the lecture and compiling these into a logical structure. The system integrates automated speech recognition, ASR, and also natural language processing, NLP, and large language models, LLMs. So LLM-based analysis is used to generate structured lecture documentation. So about the choice of the mascot, LENA is an accurate student writing lecture notes. So LENA would be an owl, quiet, observant, and wise. Owls are known for their sharp focus and intelligence, just like LENA, taking accurate notes. Plus, they symbolize knowledge and learning. So let's have a run through of LENA. So we have some keywords which characterize this tool, and the keywords are virtual assistant, teaching assistant, LLM, semantic analysis, concept mining, text summarization, topic modeling, and knowledge extraction. So knowledge extraction refers to the process of identifying and structuring useful information from unstructured text, such as lecture notes. And hence this knowledge extraction within LENA aims to transform raw text into a structured format for further analysis. And topic modeling, as we know, is a machine learning technique used to identify topics present in the texts. And this groups words and phrases into clusters that represent underlying themes. And text summarization is the process of automatically condensing a text while retaining its most important information. So this helps to reduce lengthy documents while preserving key messages. So lecture notes are a concise format of the lecture transcript, or what was spoken in the lecture. And this is where the concept mining comes in. Concept mining is a process of identifying and extracting key ideas, themes, or concepts from texts, rather than just individual words. It often goes beyond simple keyword extraction by capturing the meaning and relationships between concepts. And of course, everything happens within the umbrella of semantic analysis, which is the process of understanding the meaning and context of words, phrases, and sentences in the text. So for this tool, I used Python, OpenAI API, and it runs on a local machine. The models used here are OpenAI Whisper, Large V2, and GPT-4o. And the use case or the business process that we are doing here is lecturing, and the task being automated is taking lecture notes and post-processing these notes. The input of the system is an audio file, audio recording, usually MP3 format, but it can input also other formats as depicted on the screen. And the transformation happening in this tool is transcription. It's a knowledge retrieval, it's a structuring, and text summarization. And the output is a text file that is containing lecture notes. And the users for this tool could be lecturers, students, and teaching assistants. So the context of lecture presentation is depicted on the screen. We have here lecturer, teaching assistant, and students. So this is a traditional lecture setting where different roles contribute to the documentation and understanding of lecture content. The lecturer, for example, a professor, delivers the lecture, provides knowledge through speech and visual aids. Teaching assistant, TA, records the lecture and later compiles lecture notes based on the recording. And students take notes in real time while listening to the lecture. These are almost always not post-processed, not summarized lecture notes, and they are taken during the lecture. So we have an automated tool for lecture note compilation and summarization, and that would replace or enhance the role of the teaching assistant, namely, the activities of the teaching assistant, like manual activities, would be processing the lecture audio and transcribing it into text. Secondly, summarizing the key points using the teaching assistant's own head, and structuring these into a representative format as lecture notes. And hence the automation takes place mainly in the position of the teaching assistant, whose role would be to compile lecture notes. Here is the system architecture. This is a structured pipeline for transcribing, analyzing, and compiling lecture notes from audio recordings. A breakdown of the system would be as follows. We have first the user interaction. The user initiates the process by uploading an audio file containing a lecture. And then through the user interface, the user can configure settings and initiate the transcription and analysis processes. The processed lecture notes are eventually returned to the user and for reading or manual corrections. Secondly, the transcription process itself is when the audio file is sent to the transcription module, which converts the spoken lecture into a text transcript. This transcript is stored in the storage module for further processing. Thirdly, there is an analysis module. The transcript and lecture notes flow into the analysis module, which processes the text to extract key concepts. This module also facilitates system configuration and sends system commands for managing the workflow. Fourthly, we have fact-checking module, which ensures the accuracy of the lecture notes by verifying them against reliable sources. This module processes the lecture notes and refines them for accuracy and coherence. We have large language model, which assists in concept mining, helping to extract relevant terms and insights from the lecture transcript. It sends processed concepts and refined lecture notes back to the storage module and the analysis module for further refinement if needed. And the storage module, which acts as a central repository where transcripts, concepts, and lecture notes are stored and later archived. So the stored information is utilized by the analysis module and the fact-check module to enhance lecture notes accuracy and relevance. So the final output is when the user receives the compiled lecture notes, which have been transcribed, analyzed, fact-checked using AI. This slide describes the methodological framework outlining the system's operation and core functionalities. So first we have transcription and translation. The system initiates by converting spoken language into text through an automated transcription process. Two modes of transcription are implemented. We have an option for transcribing to original language. The input audio is processed using an ASR model, preserving the original language. And secondly, we have an option to transcribe and translate into English, where the ASR model describes the audio and an additional NLP module translates the output into English. So users select either mode based on their requirements, and the resulting transcripts serve as the foundational dataset for subsequent processing. So then we have the transcript compilation itself. So following transcription, the system compiles all transcribed segments into a cohesive document. And there might be more than one transcription because of the maximum audio file size limit. Here the compiling of the transcript takes place, and this module integrates segmented transcriptions into a structured text document, preserving the original sequence of speech. Then we have information extraction and analysis. This is to enhance the usability of the lecture notes. And for that, the system employs LLM models to extract key information components. And these components are as follows. We have term extraction. This identifies and compiles domain-specific terminology from the transcript, facilitating glossary creation and indexing. Then we have concept extraction, which detects core concepts discussed in the lecture, structuring them for better comprehension. Then we have statement extraction, which identifies key statements and claims, allowing for analytical insights and summarization. And we have also example extraction. This extracts real-world examples that support the identified concepts, aiding the contextual understanding. Once we have the information extracted, we move on to the visual representation. This is to improve cognitive processing and knowledge retention. And here the system generates graphical representations of extracted concepts. So this is a concept diagram generation, where an LLM generates ASCII art-based flowcharts for each concept identified previously, and then it integrates these diagrams into concepts, forming or combining textual and visual elements into a cohesive knowledge structure, which is to ensure a more comprehensive understanding. So basically it means that text comes with graphics. So once we have done that, we move on to lecture notes compilation and validation. This is where the system consolidates all processed information into a structured document. So the first step is lecture notes compilation, which integrates all the previously mentioned extracted terms, concepts, statements, examples, and diagrams into a unified document, providing a ready-to-use lecture summary. And then there is an optional step, which is fact checking. This is a verification module, employs LLM to cross-check extracted information to ensure accuracy and reliability. So sometimes I may make a mistake with a date or a year, or maybe a conceptual mistake explaining a theory. And then LLM can provide corrections here. And after we have produced final and fact-checked version of lecture notes, the last step is archiving and cleanup. This is the final stage, which basically copies the text files into an archived folder and deletes the temporary audio files. The original audio file remains preserved outside of the program folder. So that's not deleted, of course. So overall, this methodological framework ensures an efficient and automated approach to lecture transcription, summarization, and visualization to enhance the learning experience and accessibility for users such as students. The system output of this tool is a systematically compiled set of lecture notes structured in a way to provide a comprehensive and organized summary, still a concise summary of what was spoken in the lecture or in the class. So the process follows a multi-step approach, as we understood, that integrates machine processing, summarization, and categorization to ensure clarity and utility for users. So this is on the screen an overview of the methodological framework behind the output. First, we have metadata, which is information about the class, the course, semester, who read the lecture. Then we have four main components of the or structural elements of the final document. The first is terminology, where the tool has identified and defined essential terms from the lecture. So this process had involved the extraction of technical jargon and key concepts, followed by concise definitions to establish a common understanding. The terminology section forms the foundation of the lecture notes, ensuring that the readers are familiar with the terms before delving into more complex discussions. And these terms are selected based on their relevance and frequency in the lecture. And they are defined in a manner that aligns with academic and industry standards. After terms, we have concepts. So here the conceptual framework is presented. The tool organizes the core concepts of the lecture into thematic clusters. So these clusters represent the main ideas or topics explored during the session. The tool identifies relationships between these concepts and structures them logically to reflect their interconnections. Thirdly, we have in the output statements and key findings. The tool compiles a series of statements that summarize the most important findings and conclusions from the lecture. These statements provide a quick reference to the major takeaways, allowing the reader to quickly grasp the key points of the lecture without wading through the entire document. So these are structured in a list format. And lastly, there are real-life applications and examples where the tool further enriches the lecture notes by including real-life case studies or examples that were mentioned in the lecture, which help them to illustrate how the discussed concepts are applied in practice. And of course, within this document, there is a diagrammatic representation, which is to enhance comprehension. So these visually represent key concepts and their relationships. So the diagrams, as said previously, are designed to provide visualizations to complex systems. Well, you can read more about this tool at koppelai.eu/LENA. So in conclusion, this tool compiles lecture notes through a structured automated process that combines terminology extraction, conceptual organization, statement generation, real-life examples, and diagrammatic representation. And by integrating these components into a document, the tool has generated a comprehensive, clear, and and still concise summary of the lecture, representing a content that helps the students quickly to understand the key points and apply this information in practical settings.